So on this top diagram, this is the Steinhart calculation. This input is from the pin in the MyBrio, runs into the math functions ABC, which are provided by the datasheet, then expanding on the formula to provide the temperature in Kelvin. Obviously, if you take away 273.15, that gives you Celsius. Again, through various mass functions, you can break it down into the different SI units. If you look at this section, this is where the temperature ranges are broken down using a sequence of equal to or more than or equal to less than logic gates as such, and that provides an output which links up to the breadboard with each individual LED, the cold temperature, room temperature and hot temperature LEDs. Right, moving on to the second part. This is the beta formula. Here are the required calculations. Again, through a series of math functions, it provides the temperature in Kelvin. Again, minus 273.15 gives you Celsius, and again using the same logic gates and calculations and math functions as above provides you with the other different SI units. Moving on to the control function as such, the top is the Steinhart instruments and the bottom is the beta instruments. As you can see on both, they've got this is displayed in Celsius, and then you've got your other SI units below. On the right, you've got your three separate temperatures: your cold temperature, your room temperature, and your hot temperature. Then, if the thermistor is held on, you can see the temperature increase, and the change in the ranges lead to a different change in the status of LEDs. Again, if I let go of the thermistor, temperature starts to reduce, goes down to room temperature, and then down to the cold temperature eventually. That concludes the system, and it also shows that if you stop it, they are very similar in the temperature ranges. So yeah, that is my system.